Hello students, it's Ms. Rotinsky and I'm joining you out from the top of page 223. We're doing the second half of our 7.4 notes, which is going to be solving those polynomials when they are factored. Well, this part is actually when they're not quite so factored and we have to do a step to get them factored. So in 13 through 18, it tells us to factor the polynomial, and we're going to be using something called the GCF to factor these. So remember, the GCF, we're using the greatest common factor. So GCF, greatest common factor, to factor these. So we are going to be taking out the biggest value that is in common between the two terms and pulling that out front and then showing that it'll be multiplied by what's left of those two terms. So here in 13, we have 6x squared plus 3x. So we want the biggest, first we're going to be doing the biggest coefficient value, so just numeral. So 6 is made up of 2 and 3 is 1 and 3. So they share a 3. And then we have an x squared and an x. So the most number of x's that can be factored out of both is x. So then we are doing the inverse there uh, of what is being multiplied. So we're going to divide 6x squared by 3x. And so 3x times 2x is 6x squared. And then 3x times what is 3x? Well, that would be times 1. And right there, we have our factored form of those two terms. So, and we just used this whole idea of we're taking the biggest value that's shared between those two terms and pulling it out front of a set of parentheses and showing that if it was multiplied through the parentheses, then we would then have those two terms. So term 1 or factor 1, factor 2. So let's look at 14. We have 4y to the fourth minus 20y to the third. So 20 is specifically made up of 4 and 5. I mean, you could have broken it into 2 and 10, but we notice that the biggest number we can take out of both 4 and 20 is 4. So y to the fourth, that's y, 4 y's being multiplied together. Y to the third is 3 y's. So I could factor out a y to the third out of both of those. And then what do we have left? Well, 4y to the third times just one more y is 4y to the fourth. 4y to the third times 5, or specifically negative minus 5, is going to give us negative 20 y to the third. There is our factored form for 14. So as we're going through this page, you will be doing 15, 18, 21, and then you don't see it on yet, but 24 on your own. I'm not going to pause the video to have you work on those. I'm going to come back at the end and show the answers to those. So in number 16, we have 7z to the 7th plus 2z to the 6th. So the biggest value, we notice that 2 and 7, those are relatively prime. They're primes themselves, 2 and 7 are, but there is no number that divides both 7 and 2. So the only number that does that is 1, and we don't need to do a 1 and show that as a factor, but we notice that z to the 7th and z to the 6th, I could divide both of those by z to the 6th power, because, and that's the biggest number, the most z's that are shared between both of those. So z to the 6th times 7z is 7z to the 7th power. And then z to the 6th times positive 2 is just 2z to the 6th. So that would be the factored form for number 16. And number 17, we have 24h to the third plus 8h. So we're looking for what is the biggest number that is shared between the 24 and the 8, so those coefficients of each of those terms. Well, I know 8 goes into 24 and 8 goes into 8, so write an 8, and then h to the third and an h. Okay, so I can factor out just an h to the first, or we just write h. So then we're saying 8h times what is 24h to the third? Well, 8 times 3 is 24, and then h times h squared is h to the third. So 8h times 3h squared is 24h to the third. And well, 8h times just 1 is itself, of course. So that is our factored polynomial, but when we use the GCF on number 17. So why do we need to do that? Well, we were looking on the previous page about writing and finding out solutions to expression or equations, I should say. And those solutions were when we had a factored form. We couldn't just straight out say, "Oh, this is a solution," unless we had it in factored form, because we use that zero product property. All right, and just a quick rundown of that is, if we have two numbers and that the product of those two numbers or two factors is 0, we know one or both of those values are equal to 0. So if we multiply two things together, at least one of those is going to be 0 if our output, our answer, is 0. So here we go. It just tells us to solve this equation. So we're given an expression or an equation that 6k squared plus k is equal to 0. And we're going to have to get it factored to even start doing the solving. So we are using that GCF to get it there. So we notice that between those two terms, 6k squared and just k, there is a k in common between both of those terms. So I can factor that out front. So then I see that 6k times k is 6k squared, and then I have k times what is k? Well, that would just be 1, because we know 1 times anything is, of course, itself. And now look what we have there. We have something that looks like what we were doing last time. So we have it in this form that is factored, and now we can start setting each of those roots, is what we call, equal to 0. So straight out of the gate, well, one of our answers, we know that k is equal to 0. All right, so the only way we just say k equals 0, okay. So that's one of those easier ones that we get to do. And then we see 6k plus 1. So we're going to have to set this factor. 6k plus 1 is equal to 0. So what do I do there? I need to subtract 1 from both sides of the equal sign, and I get 6k is equal to negative 1. To get k by itself, I divide both sides and use that inverse operation of multiplication, which is division, to get k by itself, and I find out that k is equal to negative 1/6. So we could plug that back into an equation. We could be looking at our original. So if you wanted, so we could just plug in those two answers and see, does that equal 0? So if we're saying 6 times 0 squared plus 0, that equals 0. And so let's go ahead and check that other answer. If we take 6 times a negative 1/6 all squared plus negative 1/6, we see that that answer is also 0. So we did this quick check of, is our answer correct? Does that satisfy that equation? And we can see right there that what we did gives us solutions to our equation. And so we could do it there. We could see it like we did last time when we graphed it, and see that what we came up with here coincides. So just some really great things there, and some ways to check our answers. All right, let's go ahead and look at number 20. So number 20, we have 3n minus 49n squared. So one of the first things that I see is I have this written in a way that is not standard form. So sometimes it makes a better sense to me to go ahead and rewrite this in standard form. So remember, that's when I have the highest power or highest degree in my polynomial written first. So I'm rewriting that as negative 49n squared plus 35n is equal to 0. Now I'm looking for what is the biggest number that is in common between that negative 49 and positive 35. And this is one of those times when the more you do it, the more comfortable you are. Because when you have this negative and it's out front and you're like, oh, that looks messy, we kind of want to get that get rid of that and get it looking better and looking more convenient. So I know that sevens make up 49, and 7 is part of 35, and the other part of 35 is 5. 5 and 7 are relatively prime, so the biggest number I can factor out is a 7. But I'm going to attack that negative out in front of that 7. And so what that is going to do is it's going to make my leading term positive and the second term negative. So it it makes it look clean. All right, it makes it look cleaner, and for lack of a better term, it just the helps helps your brain organize and get better there. So then I can see I have an n squared and n, so the most n's I can factor out of both is just one of those, so an n So then we're looking negative 7n times what is negative 49n squared? Well, that would just be 7n. Okay. And then 7n times what is 35n? Well, negative 7n times what is positive 35. So this is when we're seeing, oh, we need to have a negative 5. And then that is all equal to 0. So now we have it factored. We have it in this factored form. Okay, so now we can set each of these equal to 0. So we get negative 7n is equal to 0. So if we divided both sides by negative 7, 0 divided by anything, that's going to let us know that n is equal to 0. Okay. And then we have 7n minus 5, and we're going to set that factor equal to 0. And using our inverse operations, we start by adding 5 to both sides. So we get our 7n is equal to 5. Divide both sides by 7. And now we have n is also equal to 5/7. Okay. Now, some of you are still not comfortable getting that as an answer. Like, you aren't comfortable getting those fractions as answers. Okay, don't stress when you're getting fractions as answers. Okay, and let's say you got that and you're like, well, is that fully reduced or not? And that's something you struggle with. Okay, convenient thing when we're looking at that is if we had a number and we had a fraction, we'll say 10/14. So do we notice that both the top and the bottom are even? Well, that's one of those things that we can check right away. If they're both even, then we know that, oh, we can reduce it. We can divide both the top by 2 and the bottom by 2 and get a new fraction that is more reduced. Now, maybe that isn't the only step you want to check. Oh, is it divisible by 3? Is it divisible by 5? Okay, so you're checking those prime numbers, seeing, okay, can I break it down any more? Can I make it smaller? Okay, so that's what reducing those fractions looks like. And if that's something you still struggle with, that's something we can continue to work on. It's not something that is always the quickest and easiest for most of us to do. Okay, but it comes with time, so we can continue to work on that. But let's go ahead and just check our answers. So we we can go ahead and put that into our original equation. So, okay, and then minus 49 times 0 squared. And we notice that we do in fact get 0. And so I'm actually going to copy, paste. I thought I was going to copy and paste. Nope, it won't let me. I'm just going to have to retype it. But we can go ahead and put in the 5/7 there. And then minus 49. And we see that we get that is equal to 0 as well. So again, those quick checks of did I get the correct answer? Um, and this is actually one of those things is like if you don't know another way to do things, like sometimes this is on a standardized test, the best way, sometimes just you're given four options, see which ones of those work, and just plug those into uh, the original equation and see, does that work? Does that make sense? So uh, those are techniques that help you get the correct answer on that standardized ACT. And I mean, you don't have like to get a 21, which is the goal for everybody. You only actually have to get like 50% of those questions correct. So uh, just any sort of trick to get one more problem right out of those 60 is huge. So if you're like, I kind of know, but I know a way to make sure I get the right answer, I'm going to do it that way. So, some thoughts there. So we're going on to 22 now. So in 22, okay, we have 6x squared is equal to negative 72x. So what we just notice here is, well, we are supposed to be able to do our solution. We need one side of the equal sign to be equal to 0. So that means we need to move all the terms over to the other side of the equal sign. So we're going to start by adding 72x to both sides of the equal sign. And that's going to undo this negative 72x and leave us with 0 on that right-hand side. So then we have 6x squared plus 72x. All right, now we are just going about our finding the GCF of those two terms, factoring out front, and then setting each of our roots, each of our factors equal to 0, and then solving for the variable. So we can see here that we have 6x squared plus 72x. Okay, so this is not always the quickest, so we're thinking, all right, 6 goes into 72 how many times? All right, well, that's going to have to be bigger than 10. So I know 6 goes into 66 11 times, and then 72 is 6 more than 66, so that means it goes into 72 12 times. So I have 6, and I can have the x. 6x times x is 6x squared. 6 times, we just discovered that, 12 is 72. So 6x times 12 is 72x. That is all equal to 0. Now we set each of those factors equal to 0. So if we have 6x is equal to 0, okay, we divide both sides by 6. 0 divided by 6. Okay, that's leading to our x is equal to 0 still, because I mean 0 divided by anything, as long as it's not another 0, is 0. And then we have x plus 12 is equal to 0. Subtract 12 from both sides, and that sends us to seeing that x is equal to negative 12. And so we have those two answers to number 22. So we have those, and we can go through and check that as well if we'd like. Going on to number 23, we have 22s, and we're going to end up subtracting that from both sides. And so now we're going to actually have 0 is equal to 11s squared minus 22s. Now, when we see this, okay, why I chose to do it that way. I want to leave my my leading value when I write it in standard form. I want that one to be positive. Because if I don't do it now, I'm going to have to just multiply everything by -1 and get it rearranged to do that anyways. So I'm just doing it right now to fix that uh, before we have to change it later. Okay, so what I notice is I have 11s squared and a negative 22s. Well, biggest values that I can factor out of both, well, 11 goes into 11 and 22. Okay, and then an s goes into s squared and s. So then 11s times s is 11s squared. 11s times a negative 2 is a negative 22s. So if we multiplied those. Now, next step is I set each of those equal to 0. I have 11s is equal to 0. So s is equal to 0. And then if I have s minus 2, set that factor equal to 0. I'd have to add 2 to both sides. And I find out that s is equal to positive 2. So those are our two answers. And if you need to go back in and check, does one side equal to the other? Well, you could do that. So we have 22 times 0, okay, equals 0 and is 11 times 0, oops, 0 squared. That is also equal to 0. So that's true. And then let's go ahead and check when that equals 2. So we have 22 times 2 is 44, is 11 times 2 squared is also equal to 44. So we see that, hey, the answer of 0 and 2 satisfies that equation because they would be equal to each other. So just some quick checks there. So that is the notes, the practice, extra practice for today. I do want you to try 15, 18, 21, and 24 on your own to just practice each one of those. So check with your teacher if you have questions, and you can continue watching if you want to see those two worked out, or four worked out. Have a great Thursday or Friday.